Anybody remember which method I like better, personally? Yeah, why do I like elimination better? You're like, I don't know why you like anything, Jeff. You like teaching math. What the shit, man? All right, so let's see. So if I had an example like, let's see, are you doing all right there, little dude? Little dude. There we go. Little dude. All right. Let's see who's working better. So if I had these two equations,
Is this because you're eliminating a variable, or?
yep. And this should be exciting. Let's see if Jeff made a good equation. So this is called a system of equations. We don't just have one equation, we have two. And sort of like, you guys know how you call it a herd of blank and a, what is it? There's a gaggle of geese and so forth, right?
Yeah.
So in mathematics, if we have a bunch of equations hanging out, we don't call them a herd of equations, we call them a system of equations, just to be different. Is that cool? You guys get that? It's the first time it just came to mind. I like that. So now I'm going to use that forever. So we have a couple equations sitting around there, and we're like, there's a system, like a little herd of equations, there's a system of equations. And for them both to be true at the same time, that's what we're trying to solve. What makes both of those equations true at the same time? How can you tell that there will be a solution? What's the only way there wouldn't be a solution? So graphically, where would the solution be? What would I do to get the solution graphically? I would do what with each of these? Graph them, and then see where they intersect. Is everybody cool with that? So that's why the solution to a system of equations, we can always write it as a point. And what does that point represent? Where the lines would meet. And why does that make sense? Because a line is all the answers for that equation. So if I have two lines that meet, that solves both equations. I like it. It makes almost too much sense. That's my hope. All right. So what's the only way I can have two equations that have no solution? Is if they don't meet, which means they are parallel, which means their slopes would have to be the same. Even without doing shit to this, can you see that the slopes would not be the same? Can you guys see that? There's no, I can solve for y and blah, blah. There's no way the slopes are going to be the same. Can you guys see that? Then I'm going to divide by 3 and there's a 4. I'm not going to get a 5. So I know there's an answer. Do you have to know that going into this? No, you don't. I'm just pointing out how everything connects. So I know there's a reason to do this problem. They should have an answer. What method would you like to use? Elimination. So let's do that first. We're going to do it both ways. Just remember how the hell to do any of this, right? It's Monday. It's been a weekend. Whatever you did, replace the math. So if I use elimination, which variable would be easier to kill? Why the y? Does it look weak? I like that. The lions, dogs, survival of the fittest and all that kind of shit. No, why is the y easier? Because I only have to multiply which one by what? Like if I add these together right now, does any letter cancel? So that's not useful. What's the problem with each of them by themselves when I say solve them is there's too many letters, there's too many variables. So the elimination method's very direct. It just says, you got too many variables, kill one of them. Right, it's a little bit, down by the docks, kill some, problem solved. So, math gets a little bit shady. So right now, if I add them, nothing happens, but what can I multiply this equation by so these would kill each other? By 3. So if I take the second one and multiply by 3, what do I get? Negative 15x plus 3y. Negative 27, right? So you multiply each one of these by 3. If you need to, write a 3 next to each one of these. Right? Be nice to yourself, whatever you got to do, because the most common mistake is you forget to do it to this guy. There's no way one side of an equation can change and the other side stays the same. And hopefully you understood what I just said. Change. Not just combine like terms. I changed this side. It is 3 times bigger, so that side has to be 3 times bigger too. We all know that. But it's so easy to forget that. And now if I just leave the first one alone, what can I do? Do what with the equations? Add them together. And I did talk about why you're allowed to do that. I feel like a lot of my colleagues never address why you're allowed to. We drill it in your head, you better do the same thing to both sides. And then we get here, we're like, just add everything together. I add 5 to this side. I'm also adding 5 to this side because that is 5. And you already talked about that one. All right. So if I add these together, what do you get? Negative 11x. The only way these can cancel is if you add them together. So, add them together.
It'd be equal to 21.
No,
No, 22.
22. Negative. And look, that looks nice. Looks like Jeff made a good one. Because what do I do next?
Divided by 11. Negative 11.
And you get x is 2. Which equation looks better to get the other letter? Why the second one? We'll take these away. Because our y is almost by itself already, right? So if I, is everybody with me?
Yeah.
I know what x is. It doesn't really matter which one you plug it in, but this one would be a little bit easier. So if I take the second one and rewrite it, negative 5 times x plus y is negative 9. Negative 10 plus y is negative 9. Add 10, y is 1. That's fine. If you stop there and go on to the next problem, you're fine. How else can you write the answer? Yeah, as a point 2, 1. If you don't do that, you're okay. But it's nice to write that because it reminds you, oh yeah, if I graphed them, they would meet here. Okay, how are we all feeling? You guys all right? Okay. You ready?
No, your math paper shirts.
Oh yeah, sorry. Yeah. You guys, whenever you hear about curved grades, does anybody know what this is called? This is a normal curve.
Is that a bell curve?
Yeah, it's also called a normal curve.
Oh.
So that's a normal distribution. That is a paranormal distribution. It's just for me, so it's all right. All right.
I have a question.
Yes.
So, do these points meet? Or
Points-
you said earlier.
Points can't meet. Points are just whatever. The 2 lines, if I graphed these 2 lines, they would meet there.
Okay. As I thought you said earlier, does it make sense? It's gonna be.
No. Again, so I was saying, why do I know there's an answer to this? Why do I know? Because these 2 aren't parallel. Gotcha. So if I see 2 lines are parallel, I know there's going to be no solution. This one, these 2 aren't parallel, so I knew there was going to be an answer. Okay, I like it. You guys doing all right?
So you can have multiple intersecting lines.
So,
Graph.
this, I want you to realize, this idea doesn't require lines. If I had remember what this guy is? What's that a graph of? You guys remember? We talked a little bit about that earlier this semester. This is y equals x squared. Right, this is y equals x squared. Is that cool? Because if you square 2, you get 4. If you square negative 2, you get 4. So that's why it kind of goes up in both sides. Because when you square something, it doesn't come out negative anymore.
Sorry, I didn't mean to say lines. I meant any point that. Well,
Now watch this.
Anything that.
I almost don't care what your question was because it didn't mean this. So I can have another line. How many answers will that system have?
2.
2. Or if the line was this, how many answers does the system have?
0.
None. Yeah. Or if it was this, how many answers does the system have?
2.
1.
1. Oh yeah. 1.
Now, to be honest, you keep this going, and they will meet, so there will be 2. It doesn't curve back on itself. But anyway, we're not going to worry about curved dudes. But the idea doesn't change. It's just that the geometry changes. Since this guy curves back, there's a possibility of more. And then if you start doing cubes and fourth powers, you get shit look like that.
So you can literally just put a line through that and then.
Yeah, so if I have a line coming through, there'll be 1, 2, 3, 4 solutions. So if I did the algebra, I'd get all 4 solutions. Thankfully, we're not going to worry with this, because this would be 1, 2, 3. This would be a 5th power right there. Let's not do that. All right. I know some of you guys some people hate it when I go a little further than we have to, but I want you to realize what we are learning now applies to more complicated mathematics, which is the whole idea of math. An idea can't change once you learn it. We just learn more things. And the idea is the same. The answer is where the things meet. And you can use elimination, substitution, or the graphical method, right? Those things can't change. Okay, so what if I were going to do this problem, substitution method? Stay with me. We're going to make it.
You're not boring, I'm just talking.
No, I am boring. Sorry. I'm a math teacher. It just comes with the whole package.
You're the most entertaining math teacher.
Which is still pretty low bar. Nothing against my colleagues. All right. So if I wanted to do this using substitution, which letter screams out to you that you should solve for? Y. I want you to really see. If I try to solve this one for x, I'm going to eventually have to divide by 4 and make a bunch of fractions. If I forced you to, you should be able to do it. I don't want to do it either. I wouldn't just choose to do that. That's stupid. So, do you guys see that guy right there? Kind of came up earlier. So if I want to use substitution, I could take number 2 and solve for y. How do I solve for y? Yeah, add the 5x. So you get y equals 5x minus 9. Is that cool? So now I know that's true. For this system that they gave me, that is a true statement. Y is this.
So you plug it into the y on top.
Beautiful. So if I take the first piece of information and use this in it, so I'm going to write 4x minus 3 times y, but what's y?
5x
5x minus 9. 4x minus 3 times y, and y is this, equals 5. And why is that better than what it was? Because how many variables are in there?
Oh, there's
One. Just
yeah.
x. I can solve that shit, right?
Yep.
So this one, there's nothing wrong with substitute. I want you to really, I don't know if you really understand. I like this method because it's more like direct. I'm just going to kill you. This one's more like, I'm going to replace you. I don't know if you guys ever saw Invasion of the Body Snatchers, but that, well, aliens going to replace humans, and Anyway, sorry. So how do you solve this?
Distribute.
By the way, you don't FOIL this, right?
No.
Because this isn't in parentheses. The only thing that's multiplying is the negative 3.
Yeah.
So it'd be negative 15 plus 27. And you can see where we're headed here. I don't know if you can see where we're headed here. See, there's negative 11x. Subtract 27. Negative 22. Right?
Yeah.
And then we know we're going to be good, because then when we plug 2 back in, we're going to get 1 for y, just like we did before. Is everybody with me? I shouldn't have to do it.
What if you plugged 5x minus 9 back into the second equation?
So anytime, so I want you to really understand, if I plug this back into itself, how many pieces of information have I used? 1. So I'm no better than I was before. So if I plug that back into itself, I end up with a true statement, like 9 equals 9,
Yep.
which doesn't help me. That doesn't actually have any bearing on what the answer to this is, because you've totally left out the other piece of information. So if you plug something into itself, it's called circular logic. It's like, I am alive because living I am. It's like, what the shit are you talking about? You can't plug something back into itself and get anywhere. So that's why you got to be really careful. You got to make sure that you use both That's why I do this. You should really start doing this. Number what you're working with all the way through so you know exactly which equation you're working with. Okay, maybe. Or don't. It's up to you. Just your teacher suggesting you do that. Okay.
So here you do all everything to know what's the line, what the kind of line, like parallel or intersecting or.
Yeah, that would be a different. I could
for
ask
this-
you.
For this thing, we have to do this thing.
This would
No.
the instructions on this would say solve. Solve using elimination, solve using substitution.
Just so.
Now I could give you a sequence, and I'm sure the book does in the homework, and they say, why do these not have a solution? Why does the system not have a solution? Well, what would that have to mean?
They are parallel.
They must be parallel. How can you show that they're parallel? What's this guy's slope? 2/3. How do you get this guy's slope? Solve for y. That's why this one was so easy. So if I solve this one for y, add 2x divided by 3. Are you guys cool? Add 2x, divide by 3. I don't care about that. What kind of lines are these?
Similar.
No.
Parallel.
Parallel.
Parallel, yeah.
Therefore, what's the solution to the system? No solution. They're parallel because they don't have the same y-intercept. They're offset, but they go at the same rate. So they're never going to hit. If the answer is where they meet and they don't meet, there's no answer.
Sorry, I kind of use the word similar, meaning that they're similar.
I got you. I kind of understood what you meant, but I want to be really specific.
Okay.
I like it. Similar is more like a geometrical idea. Similar triangles and stuff like that.
Oh, okay.
All right. How you guys feeling all right?
Those would be the same.
You guys look like you're feeling bad in general. Not even just math.
Those would be the same slope then, right?
These are the same slope.
Yeah.
Yeah. What would it take to be perpendicular? Can you guys take a minute and write down for me a line that would be perpendicular to this? Don't say it out loud, just write down. Write down a line, any line you want to, that would be perpendicular to this. Anybody else didn't get their quiz back? Okay. All right, who wants to tell me what did you guys get? I don't know if I've written this up here myself. I know the book's got this, I think. This is the symbol for perpendicular. Makes sense, nice little right triangle, right angle. So what's one possibility? Anybody write one down? Negative 7 fourths x plus 2, I like it. Right? Yeah, it says. And somebody else get something different. Did anybody else do it? Everybody drew a little duck, just so I thought you were doing something. So what's got to be true about anything that's perpendicular? This piece, right?
Yeah.
If I put anything here, anything, square root of pi to the 4th power. Who gives a shit? Are these perpendicular?
Yes.
I'm sorry, these two. These are parallel. That makes sense. So, real quick. If I have two lines that are perpendicular to another line, like these two, do you see how those two lines have to be parallel? Yeah, because they have to have that negative reciprocal slope. I like it.
So, if the slope is different, then it's perpendicular.
No. Careful. Those are two extremes. So if I just write a line down, it's probably not going to be so 5 fourth ax. And if I have another one, 1/3 x minus 2. Are those parallel?
No.
No, because their slopes are not equal. Are those perpendicular?
No.
No, because their slopes are not negative reciprocals. So can't you draw two lines that just meet at any angle you want them to meet at?
No.
I just did.
Oh, yes.
So it's probably yes. Perpendicular, they must meet at a 90-degree angle. That's why it's so specific. Parallel, it makes sense. They have to have the same slope. Perpendicular, there's only one kind of slope that makes it 90 degrees, and that's a negative reciprocal slope. Then there's a whole bunch of shit that's just neither of those, right? These guys are not parallel, but they're not perpendicular. They come together at some different
What
angle.
would they be called?
They would be called lines. Two lines that just,
Intersect,
they do intersect for sure, right? Because they are not parallel,
but they're not.
but they are not perpendicular. I like it. So would this system have an answer? Did we say they meet? Yes, we said they meet. So it would have an answer. Would that answer probably be nice to look at?
No.
Probably not. Okay, I like it. I like it. You guys, I love it. You guys are all like, that makes one of us, Jeff. All right. So I want to come back. If there's no questions from homework stuff, oh, okay. Let me get 174. Say again? I have no idea. I'm sorry. I know a lot of shit and I just put it up on the board. I'm sorry, which one? This is in 5.3. Ooh, I like. So guys, elimination method, I think is 5.2. Or is it substitution? Oh, 5.2 is substitution, 5.3 is elimination, and then 5.4 is more word problems. Now this is a word problem, number 174. The total number of calories, so it says the total number of calories, I'm sorry, Shane, can you read that for me? Total calories. What's it say? What's it say?
Two hot dogs.
2 hot dogs.
And 3 cups of cottage cheese.
Yeah, is whatever. So you guys,
960.
so do you see how this is coming up to be an equation already? So the total number of calories in a couple hot dogs and so much cottage cheese, right? Cottage cheese? What a weird little lunch. Let people do what they do. Is so much. So what do you want? What variables do I need? Hot dogs, so maybe I'm going to call that H or D or whatever. Or F if you like Frankfurter better. W, weenies, whatever. And cottage cheese. Now be careful. What about these does that mean? What about hot dogs? The number of hot dogs?
The calories.
Say again?
The calories.
Calories, there you go. Calories. So this is calories in hot dogs. This is calories in cottage cheese. Oh, that's gross, man. Let's get past it. So the first equation, the 2 hot dogs and 3 cups of cottage cheese.
960.
960?
Yes.
Sure. Gives you 960 calories. Dude, that's a big old chunk of your daily rotten dog. And then secondly, what's the other?
Total number of calories in 5 hot dogs.
5 hot dogs, dude.
2 cups of cottage
2 cups of cottage cheese.
is 1,190. 1,190.
Ja. Still less than a Big Mac. I think. Huh? No, let's not bring a third variable in this. And this is in this section with elimination, thankfully, because would you want to use substitution here? I really want to get you guys where you can see. Why is this bad for substitution? If you try to pick a letter to solve for, you're going to have to divide by something and make a bunch of fractions. Do you guys see that? Thank God they don't want me to do that. I'm not really going to make you do that. I'm going to give you an option. If you choose the wrong way, oh shit, you made it hard.
Can you do, that would change the equation, but.
Which letter do you guys want to kill? C, because the smaller numbers. I like it, right? Might as well make the numbers as small as you can. And what would you have to multiply the first one by?
2.
Yeah, if you multiply the first one by 2, what do you have to multiply this guy by? -3. To make them cancel when you add them together. They're not different signs already. So you have to make that happen in the process. So if I multiply this guy by 2, what do I get? 4H. Bless you. I think. Bless you. 6C. And then, like you said, I got to multiply this one by -3. Is everybody cool with that idea? I know the purpose of this is when I add these equations together, one of the variables should die, should cancel. What's the only way two things cancel if I add them together? If they are opposite signs.
Yep.
So what do I get if I multiply by -3 this guy? -15H. -6cc, now these want to die. I know that sounds terrible. They want to die. I don't know, this is too much. 35.7? Alright. It's my job. And now you add these together. I mean, you guys, I really want you to see that. That's almost too nice to believe. I know we don't like fractions, but hopefully you're okay if I say this is like a like denominator idea. 6, they both meet up as 6, but I gotta multiply one of them by a negative so that they want to die when I add them. Existence is pain, they want to die. So what do you hear? Yeah, 4 and 15 is evil. If it was 5 and 14, I know it's evil. Our brain goes, I got this. These go away. Say it? Yep, okay, good. And divide by -11 and hope that -11 goes in there, and it does, I think. 150. 150 what?
Calories.
Calories. In what?
Hot dog.
Per hot dog.
Cheese.
So how much in the cottage cheese? How do I get that? I just pick an equation, right? And I know H, so I can put it in either one. And if you had time, do both. You should come up with the same answer for C. Why? Because the answer has to be where these two agree, where they meet, where they agree. So which one do you want to plug the 150 in? The second one? Sure, let's be crazy. Let's do it. 5 times 150
Yep.
plus 2C is 1190. Subtract 750, I get 440. So we get cottage cheese as 220. Cottage.
Calories.
That's how you write after you eat this lunch. Very good. I don't recommend that, kids.
Why is that?
I don't know, hot dogs are disgusting as all shit. Depending, if they're, anyway, most of them, you
What
don't
if
want to
they're
know.
bratwurst?
Cottage cheese, I just don't like cottage cheese. I don't know how you feel about
So
it.
gross.
What's gross?
Cottage cheese. It's the
I
texture.
personally agree.
What about bratwurst? Do you eat bratwurst?
Bratwurst, yeah. On a pretzel bun, dude. All right. Sorry. Keep that. It's my. That's pretty much all I wanted to do today. But just remind you guys, when's the next test?
Thursday?
Thursday. So, guess what? Us crazy people are doing tomorrow.
Test review.
We're having a quiz.
Please.
Another quiz? Yeah, you're welcome. You want more grades? So tomorrow's quiz will just be no word problems, just an elimination problem and a substitution. Elimination and substitution. So just a really short, focused quiz. Which kind of sucks. Maybe I'll make it 4 questions because 2 questions kind of sucks. It's like you get them wrong, you're dead. So I'll make it 2 each. No word problems on tomorrow. Definitely in the test there will be word problems. Yes?
So when we do that process, is that elimination?
Yes, what we just did is elimination because I didn't substitute something. I eliminated a variable directly. Yeah.
So you don't have to have the same numbers to multiply with.
Exactly. Because if you had to use the same numbers here, there's no way you could ever make these the same. My God, that'd be like whack-a-mole. You just keep multiplying and multiplying and multiplying. You're like, I can't get past this one. You gotta multiply. So it is. That's why I said it's like an LCD. Don't you multiply each fraction by a different number to make the bottoms the same? Yes, same idea. Kick ass. All right, guys. Yes.